If you stand south of the 40th parallel on a clear night, you can spot the third brightest point of light in the entire sky. That point is actually a binary system known as Alpha Centauri AB. It's made up of two sun-like stars, Rigil Kentaurus and Ptolemy, sitting 4.37 light-years away from Earth. But they aren't alone. There is a third star in this system. It orbits closer to us than either of its siblings, making it the nearest star to our own sun. Yet you can't see it. It is completely invisible to the naked eye. It remained entirely hidden until 1915, when a Scottish astronomer named Robert Innes meticulously compared photographic plates taken 5 years apart. He caught a faint speck moving across the frame at the same rate as the Alpha Centauri binary system. This direct scale comparison shows exactly why Innes had such a hard time finding it. Proxima Centauri is a main sequence red dwarf star. It has an estimated mass of about 12% of our Sun, and its diameter is only 15% as wide. We naturally assume the closest objects in the cosmos are the most obvious, but our nearest stellar neighbor is a tiny, elusive shadow holding the exact thing astronomers prize most: exoplanets. A dim, tiny star might sound quiet, but Proxima Centauri operates under extreme internal pressure, making it violently active. Proxima Centauri is 40 times denser than our Sun. Its interior is totally convective. Heat and matter boil from the core to the surface, creating a highly unstable magnetic field that snaps, releasing intense bursts of radiation, a flare. This chart compares surface activity. Even at its solar peak, our Sun is dwarfed by Proxima Centauri. An estimated 88, it is locked next to a chaotic, irradiated engine. This map outlines exoplanet Proxima b. Because the star is dim, its habitable zone is pulled inward. Proxima b completes an orbit in just 11.2 days, 20 times closer than Earth to our Sun. Hugging the star so tightly carries a heavy cost. The planet is pelted with intense UV and X-ray radiation. Over time, that relentless solar weather strips away the key components of an atmosphere. It is also highly likely that the planet is tidally locked. The star's gravitational pull forces one side to constantly face the violent star, while the other side is cast in eternal night. Finding out exactly what these conditions look like on the surface is painfully difficult. A second planet, Proxima d, orbits even closer, known only because of an almost imperceptible wobble it causes in the star's light. Data for a third planet, Proxima c, is heavily disputed by scientists as a possible calibration error. Our massive ground-based telescopes have taken us as far as they can. To find out what is actually happening on these worlds, we have to cross the void and look for ourselves. Crossing 4.24 light-years is a daunting logistical problem. Using our current conventional chemical rockets, the journey would take thousands of years. But an initiative called Project Breakthrough Starshot aims to cut that travel time down to a single human lifespan. Backed by investor Yuri Milner, Mark Zuckerberg, and the late Stephen Hawking, the project intends to reach Alpha Centauri before the end of the century. To conquer the vastness of interstellar space, they have to build the smallest spacecraft ever conceived. The plan relies on the Starchip, a microelectronic, gram-scale wafer packed with cameras, navigation, and communication equipment. This diagram illustrates the propulsion mechanism. Earth-based lasers outputting 100 gigawatts of energy, the equivalent of 100 large nuclear power plants, would concentrate onto a tiny light sail attached to the probe, accelerating it to 20% the speed of light. At that speed, the probes reach the Alpha Centauri system in 20 years. They would dart through the system, capturing rapid data on the atmospheric compositions of the exoplanets, mirroring the historic flybys the Voyager spacecraft conducted in our own outer solar system decades ago. Our closest stellar neighbor proves that the cosmos doesn't conform to our expectations. It is invisible, violent, and utterly alien, and our first real attempt to reach it won't be in a massive, lumbering ship, but on a sliver of silicone pushed by beams of light.